Hello, 7th graders, and welcome to section 4.4. What are you going to learn today? Well, you're going to learn about scatter plots and lines of best fit. So, more specifically, you're going to learn how to interpret scatter plots, how to identify correlations between data sets, and how to use lines of fit to model data. So, this is probably the most important part right here. You're going to take data and analyze it by making a line of best fit, or a line of fit. So let's first explain what scatter plots are. So a scatter plot, what is it? Well, a scatter plot is a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane. Scatter plots show trends in data. So we're going to look at our first example. Our first example talks about smoothies. It says, the scatter plot shows the amounts X in grams of sugar and the number Y of calories in 10 smoothies. So basically right now all we're doing is interpreting what this means. Notice a couple of things. We have a title and we have two labels and we have X and Y labeled and then we have our numbers. Notice though on both of these that we have breaks in our graph. You can also do breaks in your graphs. So A, how many calories are in a smoothie that contains 56 grams of sugar? So 56 grams of sugar looks about right here. So 270. 270 calories. How many grams of sugar are in a smoothie that contains 320 calories? It looks like 70 grams of sugar. And then C, what tends to happen to the number of calories as the number of grams of sugar increases? I always want, I don't want you just say increases. I want a statement that is descriptive of what you're talking about. So it says, what happens? Well, as the number of grams of sugar increases, the number of calories increases. That would be a descriptive answer. So far it's pretty easy. Scatter plots and interpreting them are not that difficult, but now we're going to take a look at trends. So identifying correlations between data sets. If you have a scatter plot and all of those dots form a pattern, that's what we're looking at. So a correlation is a relationship between data sets. You can use a scatter plot to describe the correlation. So like a positive slope would be a positive correlation. That means as X increases, Y increases. As X increases, Y decreases would be a negative slope, hence a negative correlation. And then if you don't see any type of pattern, there would be no correlation. Make sure that last chart, that gets put in your notes. So just look at these, you don't need to write these down. Example 2. Tell me if the data shown is a positive, negative, or no correlation. So A, age and vehicles owned. So here's a person's age related to the number of vehicles they own. This would be no correlation. Now the next one, the temperature and coat sales, would be a negative correlation. All right, so here's the new and more complex material. You're now going to do something with your trend data, your data. You are going to draw something called a line of best fit. It's also sometimes called a trend line. When you have data that shows a positive or negative correlation, you can model the trend in the data using a line of fit. A line of fit is a line drawn on a scatter plot that is is close to most of the data points. So here's how you do it. The first thing you're going to do is make a scatter plot. Now, make a scatter plot. You can also use Desmos or a graphing calculator to make a scatter plot. Then you can decide whether the data can be modeled by a line. That means if it's positive or negative correlation. If it's no correlation, you can't make a line to model it. You want to draw a line that appears to fit the data closely. There should be, this is really important right here, there should be approximately as many points above and below it. Then you would write an equation using 2 points on the line. 2 points. Now, you could have a scatter plot with 50 points on it, but you're only going to use 2 points on the line. Now, it's important to note that the points you choose do not actually have to be points that are used in the data, but they must lie on the line. So you would then use point slope form, slope intercept form, whatever you want to use, how you want to graph it, and how you want to draw that line or whatever you want to use, but you need to get an equation. And that equation, though, once again, does not need to be 2 points on the actual data set. So now we're going to do an example of this. Here's our last example. The table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept. So the first thing we're going to do is you're going to make a graph. Now let's look at this. As x decreases, as x increases, what happens to the sales in millions of DVDs? Well, it decreases. So you're going to first make a graph of all of the points. Now I'm going to go ahead and draw this graph. And it's going to appear on your screen right now. All right, now, notice what I've done. I have drawn a line of best fit. You will notice that I have 3 lines above, 3 points above, 3 points below, and 2 points on the line. Now, it's important to note, I can't stress this enough, that this is just an estimation. What you have may not be what anyone else in the class has. But you need to have 2 points on that line. Notice here that 5, 10, and 6, 8 are the 2 points that go through this line. The 2 points that are on this line do not have to be in this. For example, let's say you decided to pick this point or this point. You can use those. They don't have to be part of the data set. Now, having said that, you could have a line that looks like this. Now, this is completely, I'm making this in red. Let's say your line looks like this. Okay, that looks like the same one. Let's try that again. Let's say your line looks something like this. The slope is not as steep. That could still be acceptable as long as you have the same number of points or approximately the same number of points above and below. So what you have as an answer may not be what someone else has as an answer. So I drew the line. Now we need to write an equation. Now once again, you can write whatever equation you would like using slope-intercept or using point-slope. I'm going to use point-slope. So y minus y1 equals m multiplied by x minus x sub 1. My slope, let's see, my slope here would be 10 minus 8, which would be 2, divided by 5 minus 6, negative 1. Our slope is negative 2. So if our slope is negative 2, I'm going to pick the point 5, 10. Y minus 10 equals negative 2 multiplied by x minus 5. I'm going to simplify this. So 2x minus 10, no, plus 10. And then I add 10 to both sides. That gives me y equals negative 2x plus 20. So there's my equation. But I'm not done. We have to interpret the slope and the y-intercept. Well, what does it mean? You do it yourself. If you interpret the slope and y-intercept, what do you get? And be specific. Here it is. Here's your answer. The equation of the line, we already said that, y equals negative 2x plus 20. The slope of the line is negative 2. What does that mean? It means that sales are decreasing about $2 million each week. You got to be descriptive. The y-intercept is 20. The y-intercept has no meaning in this context because there are no sales in week 0. So you may be asking yourself, well, wait a minute, Mr. Humphreys, how can that have no meaning? Because if you look at this, you will see that our line does start at 20. But remember, this is not the line of our data. It's the line of best fit. It is only used to write an equation. That's it. It's only used to show the trend and to write an equation. So when we look at this, in 0 weeks, if it's 0 weeks, we can't have money made in 0 weeks. So starting after week 1 is our first set of data. So in 0 weeks, it has no meaning.